As part of our class this year, we wanted to give you some examples of some different soil types. In our presentation we mentioned silts, sands, and clays. And what we have in front of us here in these three dishes is we have a clay material here, a dried out clay material. You can see it's dry, move it around. The middle one is a silt. Note how similar they look, the silt and the clay. And this is a sand, and you can see it's a little more coarser. You can kind of pick up the grains a little more. So what we'd like to show you now is some of the physical characteristics, how these react when we put water to them, and just the different characteristics, how you can roll them, pat them together, put them in your hand, and the different physical characteristics of how they react. So right now I'd like to give you this demonstration of we'll wet some material, some sand up, and then we'll look at to see what its properties are, how we can roll it, and how it performs. So right now I'm going to take a dish and put some soil in it and put some water in it and mix it up. A little dish here, put some water in. As you can see, the water soaks right into it. Mix it up a little bit, see how it takes quite a bit of water. See, it doesn't hold together very well. The thing about a sand, you don't want to get too much water in it, because then it kind of goes over to the other side and gets really hard to work with. So I've got this kind of mixed up a little bit, and I'd like to put some in my hand so you can kind of see what it looks like, and kind of try to roll it. Now you can see how gritty it is, and you can almost hear it crunch, and you can make a nice patty in it, but it doesn't seem like it stays together very well. And if you were to try to roll it and make a patty, it just falls apart. So this is the ideal example of a non-cohesive soil. The water free drains through it. It doesn't stick together at all, and it's hard to manage. And this would be something difficult in the field to really compact, because the moisture would be so sensitive that under moisture it wouldn't work very well, and if you get it over, it would fall apart. So this is an example of a very good example of a non-cohesive soil. So now we'll try to go down. As we get further down the level we go, there's silts and clays also, and so the silts will be a little more cohesive, and the clays of course will be really plastic. So right now I'd like to switch gears here and show you what a silt would look like. Well, previously we talked about the sand and how it reacted. Now I would like to look at silts, and silts are not all that common in the construction world. They're more prominent in western Montana. We do get some in the eastern part of the state, but there's something you're going to come across. It's very, very difficult to compact and identify. So I'd like to give you a little clues on how you can identify the soil and how it reacts when it gets wet. So rather than mix it up in a dish, I think it's easier to put some in my hand, and you can see how fine it is and how clay is. It almost looks like a clay. So we'll get some water here and start mixing it in. See how it kind of sticks together on my finger? So you know you're getting a little more cohesive. It almost starting to react like a clay. It really takes on the water. So we'll just keep mixing it. And for years I had a difficult time in the field identifying a silt, just because it reacted so much like a clay, and it kind of looks so much like a clay. So there's a procedure, and we kind of discuss about it in our guide, about it's called the dilatinacy test. And I was unable to really identify it until I discovered that dilatinacy test. And so you get it as wet as you can, kind of make a patty in the palm of your hand as best you can, and then you start tapping it on the side. And as you do that, I don't know if you can see it in the film, but the water starts to gloss over the top and come to the surface. So can you hopefully see that? So I've mixed the silt up in my hand, and I'm going to try to make a patty out of it. Because if you get on a silt, if you get too much water in it, it'll kind of break over the other side. So one of the identifying characteristics is the latency test. And if you get a patty like that, start hitting it against your hand, and as you keep doing that, water will start coming to the surface. And hopefully you can see this in the film, but I've got a really shiny, glossy water here, and that's because it's still a cohesionless soil. It still will drain water. So hopefully you saw that. And in construction process, it's not unusual that if you got this near optimum, you may fall over the other side, and it'll do this to you, start shakedown, and your equipment will probably drop through it. So in the past, in other projects, we've kind of wanted the contractor to be on the low side of the optimum, and actually we've gone a percent or two below the optimum. So I'll do that again. I'll mix up some more again, make a little patty, and then just hit it on your hand. And then you'll see the water start coming to the surface. And that's a telltale sign of a silt. A clay won't do that. And of course the sand wouldn't do it either, because it's just a freely draining material, drained all out. So we just got done showing you the dilatancy test on silts. Now I would kind of like to show you, we get it wet again and see if we can roll out a portion of it. It's really difficult to get it to roll. We can make a ball out of it. It's difficult to make a ball. It's still pretty sticky. So we'll get a little piece of it here and see if I can't make a worm out of it to roll it out.
Similar to a PI.
Yeah, it's similar to the PI that the lab does. So we need to get a little more water. But see, I can't, it's really touchy now. I'll put a little more water into it, but it's kind of falling apart on me now. So now, so you can see how it reacted when I put more water to it. I'm having a difficult time even making a roll out of it. It's still sticky and still wet. If I dry it out, I might try to dry it out a little bit, because it's so touchy with moisture. I'm getting a little, dry it out a little bit, see if I can't make a roll out of it. Try it up some more. So I got it too wet there. And we'll get a little piece here.
Perfect.
We're starting to get a roll on it. But see, I start to fall apart. I can't really roll it out too narrow. It starts to fall apart. It doesn't stick together quite as well. So I can't get a real narrow thread out of it. Or it starts to break apart. And that's one of the indications, another indication of a silt over a clay. You might think it's a clay initially looking at it, but the first thing you could do is try to make a roll out of it, and you can't really roll it very tight. So between the dilatancy test and making a roll out of it, I think those are two indications on how you could classify this material. Okay, we've looked at two soils now, a sand, which is a cohesionless material, and a silt, which we're starting to get a little more cohesion in it now, although because we saw the water migrating to the surface, it's not really the cohesive soil like we'd see in a plastic clay. So I've got a plastic clay here now, and as you can see, it kind of looks similar in the dish as a silt. So we'll put some more in my hand, and we'll put some water in it and see how it reacts. You can see I put some water in it, and it doesn't seem like it's getting very wet very fast. Put a lot of water into it. See, it's starting to get really sticky. And I'll make a patty out of it, again like we did the silt. It's tough to do because it's really sticky. But if we try to make a little patty there and do the same dilatancy test, you can see there's no water coming to the surface. So because it's so plastic, it's not allowing any water to move through it. So that'd be another indication of a difference between a clay and a silt if you're in the field. So we'd want to mix up some more, see if we can roll it. Try to dry it out a little bit. See how sticky it is? It's getting everywhere in my hand. Take a little bit. I'll take a little portion here and roll it. See, it's really rolling out. You can really roll a fine thread with it. Keep rolling
Back
it.
up a little bit. Oh, perfect.
It's not breaking apart at all. You're getting a nice worm out of it. Getting a nice. So you can start rolling it into a fine thread. Where the silt was a little difficult to do that, and you couldn't do it at all with the sand. So you can get a little piece here now. It's getting to be a little. See how small you can roll it out to. So that's a good indication of a clay, and she can just stuck. This material's just stuck all over my hand. It's difficult to get off my hand and fingers and stuff. So that's a really good indication of a really plastic, cohesive material, a plastic clay like this. Okay. Okay, now we've looked at those three soils. They're the three probably most predominant fine grain soils that you'll see in the field. And we've just gone through some basic properties of the three samples, some basic ways to identify them, some basic procedures on what you could use, make a roll out of it, patty it, get it wet, and just see how it forms in the field. The thing we didn't mention before is you could grab a piece of it too and clench it in your fist or your hand and see how it reacts. Might give you an indication how well it might compact. Some of those things, this is just kind of a start for you. Didn't get too involved in anything past the sand. Of course, you know you'll get into the gravels and so forth. But this is something that you could use in the field and to help identify things we need to do in compaction.